Dear students, I will explain today the vibrating string problem. The problem is here. We need to solve this differential equation with a given initial condition, and we assume the solution that this function u is a function of two variables x and t. So by separation of variables method, we write u equals to x into t, and then we differentiate and substitute it in this differential equation, and then this becomes finally this in this form, and then we have two differential equation in x and one in t. Now we solve this differential equation one by one. So consider this differential equation, these two differential equation, and initial condition changes accordingly. And now we will solve this one. So we have three possibilities for lambda. Lambda may be 0, equals to 0, maybe 0 and greater than 0 or less than 0. Then when lambda is greater than 0, then from here we have auxiliary equation m square minus lambda, and this would imply m equals to plus minus square root of lambda. So accordingly we have this solution. And now the initial condition, because x0 is 0, so when we substitute, then we get c1 plus c2 equals to 0, and this implies that c1 equals to negative times of c2. So another condition will give us another initial condition. So from here we have c2 equals to 0, so from here c1 equals to also 0, so we have a trivial solution. So similarly if you see this one, from here also we have x equals to a plus bx when lambda equals to 0. So we have solution x equals to a plus bx. This is a linear solution, and we using the initial condition we have x equals to 0, so again a trivial solution. So in both the cases we have a x equals to 0, since the solution u equals to is a product of two functions, capital X and capital T, and x is 0, so it means u is also 0. So therefore we need a non-trivial solution. So there is one possibility, lambda is less than 0. So considering lambda is less than 0, we again solve this differential equation. Since lambda is less than 0, so the auxiliary equation has a complex root like in this form. So this has solution, this one, and using the initial condition we have a equals to 0, and of course b cannot be 0, otherwise in this case also we have a trivial solution. So xl equals to this b sine square root of negative lambda, l equals to 0, and b is non-zero. So using the another initial condition xl equals to 0, we have the possibility of value of l equals to n pi over l. So from here we calculate minus times of lambda equals to n pi over l whole square. So this is called eigenvalues, and the corresponding function here sine is called eigen functions. So from here we have the solution xn equals to bn sine n pi over l into x. This is a solution for x, because there are so many eigenvalues, so correspondingly we have so many eigenfunction, we say, or solution of this differential equation, of this differential equation. So again, so two possibilities has been discarded for lambda greater than 0 and lambda equals to 0. So for those values we will not discuss the solution of this, because in that case we got the trivial solution. So we need to only discuss lambda less than 0. So no need to discuss this one. So when lambda is less than 0, we have this solution, and the final solution is given by ux xt equals to xx into tt. So we substitute here, and then ux again here involved, n is involved there, so we shall write the solution unxt equals to this much, where a and b are given, n and b are given by this expression. So this is the solution, and next I will explain in the next video. Thank you.